I'm hoping that this first one is not overly challenging, and I'm glad that I don't hear the flourish of keys being punched on a calculator. I want you to simplify. It doesn't mean solve. I don't want decimals. I want you to basically put these two fractions together. And of course, how are we going to do that? We're going to get it now. I realize, and I'm putting a lot of room in here, and you're going to find out why. If you would have had me for that particular topic when you were growing up, you probably would have had it taught to you considerably different. And maybe not. But remember, there's one number you can multiply any term you want to at any time during a problem. And what number can you multiply by any time you want, pretty much? 1. But remember, 1 can take various forms. As long as it's 1, you can multiply any term by that you want. And we know that we need a common denominator. And more than likely, what's that common denominator going to be if I'm sitting here looking at a 3 and a 4? Probably 12, right? And so what do I have to multiply this bottom by? I have to multiply it by 4. So you also have to multiply the top by 4, right? Because I'm multiplying particular terms by something. And am I technically multiplying the 1/3 by 1 then? Technically I am, right? So is that legal? If I'm just multiplying one term by something, yeah. What if I tried to multiply it by 4? Is that okay? No, then I'd have to multiply everything by 4, right? But if you can pick any term you want and multiply it by any form of 1 you want. So what am I going to multiply this one by? Yeah, 3 on the bottom, right? Because I need 12, right? So you see that? And so what really happens is this becomes, the beauty of multiplying is you can just multiply straight across, right? 4 over 12. And inevitably, somebody wants to say, oh, that reduces to 1/3. Well, of course it does. It was 1/3 just a second ago. Okay? We're putting it in disguise so that we can actually use it. This one is now also over 12, and it is a 9. Agreed? And when you add, this is always a point of interesting too, you'd be surprised how many times in advanced math I've been told that's 13 over 24. And that's normally when things get thrown. 13 over 12, of course. And 13 over 12 is good. I have no problem with improper fractions. But I do have a problem is if maybe it's something that could be simplified. Does everybody understand that that is the correct answer to your first one? I don't have a problem with that, but I do have a problem if it would say something like this. I don't have a problem with 14 over 12 being improper. I have a problem with it not being simplified. Okay. Because what obviously comes out of both of those? 2, right? And so you should have 7 over 6, okay, if that happens. That doesn't happen on this problem, but if it were to happen, please make sure you take care of that. Are there any questions so far? Let's just get rid of that so that we don't have any confusion. The answer to this is 13 over 12 or 1 and 1/12. Okay. Is how you could simplify that, put it together. Well, obviously that's not the whole gist of what we're going to do today, but it does get you started as to how I look at these. You can multiply any term you want at any time by 1. Of course, you knew there had to be some kind of variables happening here somewhere. And lots of them, correct? So if we are going to try and solve this, it would be extremely helpful if I could actually add the things together, right? And they are fractions on the left side, correct? So I'd like to be able to add, subtract, and be able to work with things. And so what we're going to do is try and get it so that there is a common denominator. What we're actually looking for is one of those little alphabet deals, right? LCD, one of those acronyms. Lowest or least common denominator is what we're looking for. And I'm just going to write them real big again so that I can write stuff next to them. Remember, it is always okay to go more than what you want. For that last example, could I have gone to a common denominator of, say, 24? Right? I could have gone way higher, right? I could have gone as high as I wanted to. As long as it was a common denominator, I just would have had to simplify more. That's why we say least common denominator. It saves you time. And so looking at that, I have a 2n, a 3n, and an n. They all already have an n, right? So am I worried about the n in this case? No, they all have that, right? But they don't all have a 2 and they don't all have a 3. So it's very important to see where you need to go. What is going to be the least common denominator here? I know there's going to be an n in it, right? That's a given because they already have an n. That's done. There's nothing I can do about that. Okay. 6, right? 6n. Very good. That's where I'm trying to go, right? I would love to have that because then I could actually do something with this problem. So I'm going to sit here, and each one of these terms I may multiply by something slightly different. But as long as that piece that I multiply by is 1, I'm okay. So I know I want 6n. So do I have to multiply by 3 or 3n? Just 3, very good. But then I better do that up here as well because I multiplied by 1. I picked that term, I said I'm going to multiply by 1. Here it is, I'm multiplying by 3 over 3. And so maybe I should just go down like this and write it. 3 over 6n. Again, it's very difficult to not want to simplify that, isn't it? You see the 3, the 6, you want to simplify it. But then you're right back to where you started. Okay? So now, plus. How about this one? We need a 2 or a 2n, or what do you got? This 2. So do you see how the forms of 1 can change from term to term? So we know this is 6n. So is that 6n minus 92? I mean, that's kind of what the top looks like now. Right? Be careful. Right? Here's how you might want to write that. Right? That's how we write when we have to times it through everything, right? So that one comes down here. Six, right? It should be no surprise that none of the forms of 1 that we chose are the same. If the form of 1 we choose is the same, we probably could have combined like terms before we even started. Right? If you're going to multiply with the same form of 1, you should have combined them before you did anything. Right? And what do we got here? Is there any discussion about how we got to where we are at right now? Now, this very first time I'm going to show you this maneuver, and then I'm going to pretty much let you go on that and kind of just let you, in a way, just cancel things off. Now that we have a common denominator, I could add the left side together, right? If I wanted to, I could subtract, I could do lots of things, right? Here's how I look at it. Once you have that common denominator, let's be honest, none of us are really big fans of fractions. So if we could get rid of them, that'd be awesome. And that's exactly what we're going to do. In this problem, there's something I could multiply by right now that would get rid of every single fraction in that problem. You agree if I multiply everything by 6n, everything's gone, right? How did I know it was 6n? Really, it's 6n over 1, right? How do I know it's 6n? Because that's my denominator. That's what I'm trying to divide by. And do you agree if I went through and multiplied every term by that, that it would just cancel? Right? So if I multiply this term, do you see? Cancels. But if I multiply this by 6n, cancels. 6n, cancels. So then what's really left is just 3 plus do you agree that's all that's left after I do that? So if you can get a common denominator on every term, here's normally what I do. Once I get the common denominator, I just kind of do this. Gone. And I just deal with what's left. Because really, what did I do? I turned around and multiplied by that. But I multiplied everything by that, so that's why it's okay. Okay? So now we have to solve this. Well, that's not that hard, is it? That's down to the algebra you've done since Algebra 1. Right? It'd be 3 plus, what are we going to do here with the 2? Yeah, distribute. What is that? 12n minus 18 equals 12. Now you probably should combine the 3 and the negative 18, right? So we've got 12n. What is that? Negative 15 equals 12. Yeah, sorry, that got a little low on the smartboard there. Everybody see that I just combined the 3 and the negative 18? Add 15. So 12n equals 27. And divide by. And is apparently 27 over 12. Based on what I told you earlier, is it okay for me to leave it that way? I heard some yes, some no. Why not? Yeah, I can actually simplify, right? So it's not the improper that I'm worried about. It's the fact that what number goes into both? 3, right? So 27 divided by 3 is 9 over. And a lot of you that have relied on guess and check for a very long time are really starting to find out it doesn't work as well as it used to. Because I don't know too many of us that guess 2 1/4 as our question. And so let's recap. We were given there was just variables everywhere in this thing when we started. And so we got a common denominator. And once you get that common denominator through everything, you just go ahead and you cross it off. Okay. And then you solve what's left. And then what was left was only one variable, so it was much easier. And it was 9/4. Okay. Are there any questions as to what you saw there? I will always recommend that you actually substitute it back into the original to make sure it works. But it does. I checked. Any questions of what we did? Well, let's see how well you do on this one then. That's a lot of variables. And you know what? There may or may not actually be a t-value that works, and there may be more than one t-value that works. I know that because I see a t-squared in there. What did we do first on the last one? We tried to figure out what the LCD was, right? Well, I'm looking at that last term. That's actually where I'm looking. And I may see something that you don't. I'm going to spread it out again. Anybody want to alter what that looks like? The last denominator? No, not quite a difference of 2 squares. Well, if we put the square root of t in there, maybe, but I don't think we want to do that. Yeah, the old standby. I guess we could do that if we wanted to, right? You know, they have a t in common, correct? Now, do you have to do that? Not really, because remember, I told you could always go higher than you need. Like that first example, I could have gone to what, 48 if I felt like it, right? But 6 happened to be, or no, 12 happened to be our lowest denominator. Yes. Oh, there isn't? Do you have one on yours? Oh. That was me thinking there was one. That wasn't me checking, but good job. Not really. I could always go with that, but that's not what happened. There are a lot of times I do that though, but this wasn't one of them. All right. Now, why would I rewrite it that way though? Why rewrite that way? I think it makes the denominator. Do you see those two pieces in the other two denominators? Okay, would you have seen them originally? No. So always look for that. See, well, what does that really mean? And sometimes maybe you can factor it, you know, so watch out for that. A lot of you tried difference of 2 squares on this one. That probably will happen at some point, a difference of 2 squares. So I like to kind of figure out the LCD before I even get going. Because let's face it, if you don't know where you're trying to get, it's kind of hard to get there. And really, remember, there's an old standby, and we kind of almost did it on the first example. Let's say we really got stuck. What's one way to find a common denominator? Just multiply them, right? 3 times 4, we happen to get lucky, right? It happened to be right. So could we really do this? If you really get stuck, just multiply the two denominators, at least on one of the sides. So I could take t times t minus 4. Let's see if that's helpful. We know that's at least a possible common denominator, right? And look what just happens to be the denominator on the other piece. Same thing, right? So can we get them all to say the same thing? That's really our goal. We can. And that is our least common denominator, because that already is the denominator of that piece. Okay? So now our form of 1 is going to get a little bit more complicated. Again, you can pick any term you want and just go ahead and multiply by 1. So look at the bottom here. What part does it not have? The t minus 4, right? So do you see the form of 1 is getting a little bit more complicated? But it's still 1. I hope you agree with that. T, right? And I kind of like to start throwing parentheses in so I don't get confused. What do I have to multiply this one by? Yeah, nothing. So if you really wanted to write something, you could say 1 over 1 or something, right? If you really felt like you had to write something, but you don't really have to. So does every term have the same denominator? Now, what did we really do back here? We really multiplied by that denominator, but in essence, what did it do? What did multiplying by the denominator do in this last example? Got rid of all the fractions, didn't it? If I multiply by t times t minus 4, is it going to do the same thing in this problem? It's going to do the exact same thing again. It's going to cancel off all your denominators. And so all I have to solve is that. So we've taken it from a problem that had 1, 2, 3, 4, 5, technically I guess 6 t's in it, if you count t squared as 2 of them. And now we're down to much fewer. It's the same problem though, in essence. Well, what are you going to do then? I still got to solve for t. How are we going to go about this? With what we have in green here. Yeah. Not quite cancel, because they are multiplied together. Yeah, FOIL it out, right? So, t squared minus 4t, right? And then you turn around and do plus 4t. And the most important part to do right is normally the last part, minus 16. Everybody okay that that's just that FOILed out? The beauty of it, it was a difference of 2 squares basically set up. 1 minus, 1 plus. So we knew of FOIL, the O and the I should have canceled, which they do. Okay. Do you agree that would be the rest of it? I hope. And as mentioned, those two should cancel. So t squared, maybe I'll just write it out so you can see it. I hope you see that if once we cross that off, that's what we have. Well, if we're going to try quadratic on this, we kind of want it in order, right? Descending order. And we want it to equal what if we're going to try quadratic? Equal 0. Does this equal 0? No, it equals -16. So we probably want to move that, right? But what very nicely happens? Yeah, it cancels on both sides. Is that always going to happen? No. But, you know, when it does, you might as well just let it happen. Equals 0, right? Could you use quadratic on that? A is 1, B is 3, C is 0, but you don't need quadratic. Can I erase the LCD so I have this room over here? Everybody's good with that? I'm assuming. Nobody screamed, so I think I'm okay. Yes, quadratic works just fine because it is a quadratic equation, so it's fine. Anybody see a little quicker way, maybe? We kind of did it earlier. Don't the two terms have something in common? T. What's left? T plus 3 equals 0, right? Now remember, this little trick only works when it equals 0. So I have to find what's going to make that say 0 or what's going to make that say 0, because it's multiplication. So what if I set t equal to 0? Well, there's not a whole lot of work to do there, is there? Well, how about t plus 3 equal to 0? You get that t would equal what? -3, right? Again, I want to just point this out because some people really don't have this part down right. So just cover up the -3 for a second. Putting t for 0 means I have to substitute it in both places. So it's 0 times 3, right? But who cares? You agree it's still 0, right? Same thing with -3. I have to substitute it here and here. But this is 0, this is -3. But again, who really cares? It's 0 times -3. It's 0. Right? You see, that's why that works. That's also why it doesn't work for any other number. Okay? Now, t doesn't necessarily stand for time here. But I mentioned something on the last example at the very end. And I said I did it for you. And it worked. Yeah, you better test it out. Now, why is that? Well, do you agree we got down to something parabolic or quadratic? That's a parabola. Doesn't know what type of problem I'm trying to solve. All it knows is that it hits the x-axis twice. And it hits it at -3 and 0. One of those two doesn't work. And who can tell me which one doesn't work and perhaps why? Yes? Yeah, am I allowed to put 0 back into this original equation? I don't know why I called it original when it's original, but anyway. Can you put it in there? Can I put it in this numerator? Yeah, before, right? But I'm dividing by 0. Ooh, yeah, that's not good. Does -3 cause similar problems? Nope. And believe it or not, if you put -3 in, it actually works out. That the left side actually does equal the right side. Okay. And I can't really imagine any of you that would look at that original and, -3. Okay. So guess and check, again, kind of losing its power a little bit because of the algebra that has to be done. Any questions on what you've seen today? No? All right.